Good afternoon. Chapter 20, Video Technology. We're going to look at the current video technology, equipments used for security, and how everything comes about. We're only going to focus on the last decade, last second half of the 2000s, so last decade or so, 15 years. How LANs, WANs, Wi-Fi, internet, and how it's all changed. Even since COVID, there's been a huge change in the way videos, cameras have gotten so much better, smaller. So we're going to take a look at that. We're going to look at the different technology, camera functions, lens functions, transmission. So we have a lot to cover today. Here's all of our wonderful keywords that we're going to look at. So the second half of the 2000s witnessed a quantum jump in video security, such as digital cameras, multiplexers, digital video recorders, DVRs, and second significant activity, integration of security systems, computer-based local area networks, wide area networks, World Wide Web. Basically, everything came together. Today's video secure system hardware is based on new technology. It takes advantage of the great advantage of microprocessors. Things have gotten smaller, faster. Think of NVIDIA, their chips, what they've done. Not that they have them in here, but this is how technology has changed. Wireless transmission has gotten so much better in the last couple of years than it ever was, and we're taking advantage of that. The microprocessor has changed. Faster, smaller, digital processing, monitors, everything has changed in the last couple of years. A lot of it since COVID, actually. Primary function of any video safety is to provide remote eyes for security force located at a central console or remote site. Right? That is what we want to do. To make sure that someone can see what's going on. ADTs, what I have here at my house, someone is monitoring it. If there's something going on, they can see, talk through the speakers. So it has definitely changed on how it's gone. Video recorders are optional. A camera may be used as monitor for employees, visitors, people entering the area. Everything now gets recorded so we can see what's happening in the world. Illumination source. We talked about how important lighting is. That becomes just even more important now as the cameras have changed. So we want to have the cameras. What's seen is that's what's being recorded, the person or activity that's happening. And the lens is the camera that's recording it. Transmission, coaxial, is still one of the common ways, but wireless is becoming even more standard on what's going on today. Let's see. So we have some other things going on. Cameras, video switchers. Let me find out. Some other equipment that we need to have. Supporting equipment, cameras, multiplexers, video motion detectors, and all these, so when things happen, we can see what's going on. Basic camera that we should have every system that we need to have at a minimum. The housing is the camera that we have, everything that fits inside, scenes, the splitters. So all this comes together in what we need to build. The basic camera that we have to have. It doesn't matter how big or small your company is. You have to have a lens, a camera, transmission link, and a monitor. This is the standard minimum setup that is required. We should have some kind of video printer and some kind of recorder also so we can capture what's going on. But at a minimum, you have to have these 4 items in order to have some type of setup. Camera switches, some auxiliary support switches that you can have, camera switches, transmission links, housing, dome housing to protect everything, plug and play cameras, pan tilt mechanism so someone can zoom in and out as they need. Video technology, surveillance must have a device and is an analog video system, digital signals, digital videos, and these are some of the other ones that they could have at a minimum. Essentials for CCTV, as we've talked about in previous, the importance of the CCTV has multiple cameras, electronic switch, lenses, quads, multiplexers, so it can have multiple things going on, so we know what's happening around everywhere. We can have as many as we need. Again, it goes into a multi-switcher to a monitor, possibly multiple monitors, printers, and the video system. Essential is the CCTV, illumination, so we're going to take a look at this, the role of lights. What kind of light is there? Sunlight, moonlight, starlight. We should have, and we talked the importance of lighting areas so we can see what's going on in our parking lot, because we can't rely on, if it's cloudy or rainy, we might not have any light, so you have the different lights. We covered that a couple of weeks ago. Amount of light reflection, normal scenes, 25 to 65, snow-covered scenes up to 90. The amount of light received by the lens is a function of the brightness of the light source, the reflectivity of the scene, and transmission characteristics of the interfering atmosphere in the outdoor application. The scene back to the camera, therefore transmission through the atmosphere must be considered. When atmospheric conditions are clear, there's generally little or no attenuation of the reflection light from the scene. However, when it's participating rain, snow, and other, dusty, smoky, likewise hot climates that could cause issues. Thermal effects, heat can have issues also. Since most solid-state cameras operate in visible light near IR wavelengths region, the general thumb with respect to visibility is that if a human eye cannot see the scene, neither can a camera. Under this situation, no amount of increased lighting will help. However, if the visible light can be filtered out of the scene and only the IR portion, it could be good. Problem is often overcome that IR imaging camera works outside of the visible wavelength. These thermal IR cameras produce a monochrome display with reduced image quality, and they are much more expensive. The charge coupled device, CCD, or complementary metal oxide semiconductors, CMOS cameras. Illustrate the difference between it. The lenses on the camera form an image of the scene and focus into the sensor. Almost all video systems used in security systems have a 4:3 aspect ratio, 4 units wide, 3 high, for both the image and the FO. The width of the parameter is designated as lowercase h and uppercase h, and the same with vertical for that. Some cameras have a 16:9 unit of the high definition. The camera lens of the human eye collects the reflective radiation from the scene, much like the lens on your eye or a film camera. The function of the lens is to collect reflective light from the scene and focus it into the image onto the CCTV sensors. A fraction of the light reached of the scene from the natural and artificial illumination source is reflected towards the camera and intercepted by a collection of camera lenses. As a general rule, the larger the lens, the more light will be gathered. The brighter the image on the sensor, the final image will be. Most video applications use the fixed focal length, or FFL. The FFL lens, like the human eye lens, cover a constant angular field of view. The FFL lens emit images of the scene with constant fixed magnification. A large variety of CCTVs allow for that to carry on. And when you can have that zoom also. Most cameras have the iris diaphragm, a just open area of the lens to allow correct amount of light through. It can either be manually or automatic iris, depending on what you want it to, how it's set up. Camera function. The lens that is seen on the camera image sensor, which acts like a retina of the eye or film in the photographic camera. The video camera senses electronic converted to visible image into the equivalent of the electronic light. The camera converts the optional image produced by the lens into time-varying electronic signals that change in accordance with the light intensity distribution throughout the scene. Other camera electronic circuits produce synchronizing pulses so that the time-varying video signal can later be displayed. Almost all cameras must scan the scene point by point as a function of time. Solid-state CCD and CMOS color monochrome cameras used in most applications. Low in illumination, sensitive CCD cameras with IR built in for the sensitivity. In the early 1990s, tube color cameras available for security application lacked long-term stability, but allowed for color cameras to be used widespread. Transmission. Once the camera has generated electrical video signal representing the scene image, the signal is transmitted to a remote security monitor site via transmission coax cable, 2 wires, twisted pair, LAN, WAN, internet, or wireless, whatever works, whatever we're set up. The choice of transmission medium depends on other factors such as distance, environment, and facility layout. If the distance between camera and monitoring is short, 10 to 100 feet, coaxial cable and fiber optics are used. For longer distances, 500 feet up, or as electronic distribution, fiber optics cable would be preferred. For long distances, such as harsh environments, frequent lighting, storms, or between separated buildings where there's no electrical grounding between the buildings is in place, fiber optics is the choice. Monitoring site, CRT or an LCD screen to monitor what's happening in there. It's usually visually image on the monitor, face via electronic. The vinyl scene is produced by scanning electronic beams, the CRT, which is the old term, and then everything could be backed up into the recording onto a VCR or today a DVR. For decades, VCR was the most common, but they have issues with the tapes degrading. They were used over time. Usually quality was very bad after several months of using the same tape, and would become useless. DVRs are a lot more user-friendly. They don't overwrite. You can save a lot of data. You still need a big storage area to back up all the data. We talked about illumination already a couple of weeks ago, but it's also super important. There's natural light and artificial light during the day. You sometimes still need lights if it's in a garage or overhang, so we want to look at that. During the daytime, the amount of illumination or spectrum distribution of light reaching the scenes depends on the time of day, what's going on. Is it direct sunlight? Is it overcast? All this has to come into account. If it's cloudy, do we have lights to supplement the daylight in the sun? If it's raining, do we have lights? Again, at night, what do we have? Are the cameras automatically adjusted to make sure that everything is being caught up? As we mentioned in the previous weeks, everything's measured in foot candles. Typical daylight's about 10,000 foot candles. Night, moonlight, it can be detected, sensitive monochrome, and without moonlight, local man-made lighting sources, as we've talked about. No natural light requires an ICCD. Monochrome cameras and IR LED illuminations, thermal cameras are what we need. And all this could be measured in lux. Artificial light. This is often used as the argument for outdoor lighting to obtain adequate video surveillance. The light source is used as tungsten, tungsten halogen, metal arc, mercury, sodium, and so on. As we talked about all these earlier in the thing, it's not just for safety, but we need it to record. The type of lighting depends on the architecture of the equipment that we have. Where if it is hallways or overhangs, we need something in there so that we can have some type of light, specific applications, safety reasons, improving video picture so people can see, as we talked about all these different things. Balanced colors and the most efficient visual outdoor light types are low and high pressure sodium vapor lamps, to which the human eye is most sensitive. These lamps, however, do not produce all colors, missing blue and green, and therefore are not good light sources for color cameras. Metal arc lamps have excellent color reduction. Mercury arc lamps provide a good security illumination, but are missing the color red. Therefore, they are not good for everything that we need. LED IR illumination array mounted in a monochrome video camera or located near the camera are used to illuminate scenes when insufficient lighting. Indoor lighting changes between daytime and nighttime operations. Then an automatic iris lens or electronic shutter camera is required. The illumination level for most indoor lighting levels must be indoor lighting significantly lower than 100 to 1,000 times. The quality of the video depends on the various scenes. Characteristics include the scene lighting level, the sharpness and contrast, whether the objects are simple or uncluttered, whether objects are stationary or motion. The scene factors will determine whether the system will be able to detect what's going on. Target size. In addition to the scene's illumination level, the object contrast with respect to the scene background, the object apparent size, that is field of view, as seen as the cameras, influence the ability. They must detect the object or the movement in the scene, determine if the object's orientation, recognize the object, an adult, child, car, truck, and identify of the object. Who is the person, exactly what kind of truck, and identification. Making these distinctions. Making these distinctions depends on the system's resolution, contrast, signal noise, In a typical scene, the average observer can detect a large amount, 1/10 of a degree, in angle. This can be related to the standard video picture that has 525 lines. The National TV System Committee, NTCS, and about 350 lines of vertical, what can be seen. Reflectivity of different material varies greatly depending on the composition of the surface. Gives examples of materials as we have. Color scene is more complex, although the reflectivity of a red box in a green wall may be the same as the average over the entire visibility spectrum of blue and red. The color camera can distinguish between green and red. It's identified some characteristics by the difference in color and a different scene to make it easy. For this reason, the target size required to make the identification of the color scene is generally less than that. A moving object in a video image is easier to detect but more difficult to recognize than the stationary one. That the camera can respond to an LLL. Cameras produce sharper image for stationary scenes but smear the image for moving. So a solid state CCD or CMOS do not exhibit the smear or lag of normal motion. So it depends. What are we trying to catch? If a target moves very fast, the scan rate can cause it to blur. Moves fast, inherent camera rates are 30 frames per second, causes a blurred image of moving the target. The blurred image is still photography when the shutter speed is too slow for the action. So we need to make sure we have the right camera for what we want to capture. Temperature has no effect on video imaging. These sensors do not respond to temperature change or temperature difference in the scene. On the other hand, IR thermal images do not respond to temperature differences in the scene. Thermal imagery do not respond to visible light and very near IR sensitivity. A lens collects the reflected light from the scene and focuses it onto the camera image. The lens of the human eye focusing a scene or onto the retina, black eye, as a human eye. The camera lens inverts the scene image just like it does on the camera. Different types of lenses for video surveillance and safety applications. The FFL manual iris lens is more complex, variofocal, and zoom lenses. In addition to pinhole lenses, they convert to applications for split images, scenes for viewing multiple things up on the axes. Wide field of view can be very large scenes. Narrow field of view, telephoto lens, high magnification, high resolution. Zoom lenses, complex. Overall, camera lens field of view depends on the lens of the FL and camera sensor size. Zoom lenses consist of multiple lenses groups that move within the lens barrel by means of an external zooming ring. Field of view without having anything on it. Could usually zoom focal length to go 6:1 or 50:1. Varifocal lenses. Lens application where an FL lens would be used. In general, they are smaller and cost much less than a zoom lens. Like zoom lenses, the varifocal lens is used because of field of view. Can be changed manually or automatic using a motor by rotating the barrel. Panoramic 360 lenses all around the entire room or the location, seeing 360 degrees. One panoramic camera lens are available. They are available for many years and provide an awesome thing. Usually be mounted in the center of the room. Convert pinhole lenses, specialty lenses is a lens with a CCTV camera, must be hidden. The front lens element or aperture is small, a 1/16 to 5/16 of an inch. Although the size is not a pinhead, it nevertheless has been labeled such, as you can see how small it is. Special lenses are all different things. Split images has multiple images, right angle lens, flexible or rigid, just depending on what we need to have. The camera lens focuses the visual scene onto a camera sensor area point by point, and the camera electronics transfer the visible image to electronic camera video signal. Maybe up. Almost all security cameras today use monochrome CCD or the rapid remotion of the CMOS. Less cost, more expensive cameras in a housing are larger, more rugged, have that available. Analog and digital surveillance cameras at disposal. Up until the mid-1990s, analog cameras dominated with only rare digital cameras being available. Digital internet cameras were only introduced to the security market, advances in solid state. The internet were responsible for rapid use of digital things. Again, a lot of this since COVID. Two methods used in a camera monitoring system process. In the past, analog video systems have all used the raster scanning technique. However, new digitals use the progressive scanning. All cameras use some form of scanning to generate the video picture, block diagram of a CCTV. Camera sensor convert the optical image from the lens into the electrical signal. The camera electronics process the video and generate a composite video. Signals transmitted is called a frame. A picture video is made up of two fields of information. Each field transmitted is either 1/60th or 1/30th of a second repetition. The NTSC system is the first picture field to grade by scanning 262.5 horizontal lines. The second field of the frame contains the second 262.5 lines, which are synchronized so that they fall between the gaps of the first field and producing that, coming up with your 525 lines. The second field starts at the top, and each time the line ends, the field transfers from the left to the side of the scan to the right and corresponding horizontal. Random interlaced cameras do not provide complete synchronization between the first and second fields. The horizontal and vertical scan frequencies are not locked together. Therefore, the fields do not interlace exactly. This condition, however, results in an acceptable picture. an asynchronous condition and difficult to detect. The 2-in-1 interlace system has an advantage when multiple cameras are used with the monitor. The digital scanning is accomplished in 2-to-1 interlace mode as the analog system or the progressive mode. In the progressive mode, each line is scanned in a linear sequence, line 1, then line 2, then line 3, and so forth. Solid-state camera sensors, the monitor's display can be manufactured with the horizon. Standard ratio is 4:3, wide is 18:9. Some standard formats for color: CCD cameras 512 times 492, and so on. As you can see, TV lines, the LCDs are 1280 by 1024. Video security cameras have gone through a rapid technological change since the first half of the 1980s to present it. For decades, the Vidicon tube camera was the only security camera available. In the 1980s, a more sensitive, more rugged silicon diode tube became available. The invention of the digital CCD and later CMOS cameras became a lot more popular. The technology coincided with rapid advancement in digital DSP cameras and IP when we had the LAN, WAN, everything being transmitted over that. Solid-state cameras, the first generation of solid-state camera available had a 3-inch, 2/3 of an inch sensor diagonal and a 1/2-inch sensor format. The technology improved, smaller formats evolved. Most solid-state cameras used today are available of 3 image sensors, a 1/2-inch, a 1/3 inch, or a 1/4 inch. The 1/2-inch 0.89 format produces a higher resolution. Formats: the 1/4 inch cameras are excellent resolution with light sensitivity, solid state sensors, precise, repeatable pixel geometry, low power requirements, small, excellent on what's going on. Analog cameras have been around with the CCTV, have been used in security. Their electronics are straightforward. Digital: since the 1990s, there has been an increase in use of the digital DSP in cameras. It significantly improved the performance of cameras by automating, adjusting to large light levels changes, eliminating that, and automatically switching cameras. The internet. The camera is configured with electronics that connect to the Internet, World Wide Web network through Internet service providers. Each camera is provided with a registered Internet address and can transmit video image anywhere on the network. This is really remote monitoring. The camera site is viewed from anywhere, entering the camera Internet address with the login and password. When security applications require viewing during nighttime conditions, where available light is moonlight, starlight, or other residential residual reflected light, and surveillance must convert to non-active illumination, like IR LEDs, CCD cameras, sensitivities that we need to have. Thermal imaging cameras, called IR. Visual cameras can see only visible light from the blue end visible spectrum to the red, approximately 400 to 700 nanometers. Some monochrome cameras see beyond the visible region into the IR. Some cameras can use the thermal sensor to pick up that. powerful mathematic techniques. We have the 360-degree panoramic lens. In operation at the lens, it focuses 300 degrees horizontal up to that with the donut hole in the center. Small scenes area is mapped onto the sensor until the full scene is mapped. Powerful mathematical editor, only a small section of the entire scene on the screen at a particular time. The main attributes of the panoramic system: capturing a full 360 field of view, the ability to digitally pan tilt to anywhere in the scene, having no moving parts, no motors, having multiple operators, requires a high resolution camera. Transmission: the camera must be remotely located for a monitor, and therefore the signal must be transmitted by some means from one location to another. In security applications, the distance between the camera and the monitor may be from 10 feet to several miles, perhaps completed around the globe. Transition paths by the building outside that we need to look at. The signal can be either analog or digital. It can be transmitted via electronic, either coaxial or cable, LAN, WAN, hooking to the internet. Once it's hooked to the internet, we can see what's going on. We can have coaxial cable, UPT, internet, large security systems, fiber optics, whatever we want. Coaxial is the most common transmission. The cable's used since the inception of CCT and is still used today. The cable's inexpensive, easy to terminate at the camera and monitor ends, and transmit full video signal with little distortion. Has 75 ohms electric impedance. Copper shield works well up to 1,000 feet. Unshielded twisted pair. In the 1990s, this technique used transmitted camera and receiver at the monitor with a twisted pair copper connecting. Several reasons for this: increased popularity, can be used over long distances, inexpensive to wire. Many locations already had 2 wires twisted pair installed. Uses low transmission and receiver. It has a high electrical noise, and it can be transmitted up to 2,000 to 3,000 feet. LAN, WAN, internet, revolutionized transmission, wide speed now. We just connect it to the internet, and it allows the connection to be seen with the proper connection around the world. Video signals transmission technique described so far provided a means for real-time transmission. Full 4.2 megahertz bandwidth to reproduce real-time motion. When these techniques cannot be used in real time, alternative digital techniques are used. Wireless is becoming more economical and beneficial to transmit real-time video without cables from cameras using RF, IR, atmospherical link. The digital video uses digital transmission used to wireless networks, Wi-Fi. Permits routing to the video and controls signals to remote, both analog and digital systems for scrambling the signal. 3 important applications: convert and portable, rapid deployment for video installations, building-to-building transmissions over roadways, parking lots, poles. They can be set up just about anywhere. The FCC restricts some wireless transmission devices using microwave frequencies, RF to the government law enforcement, so there's only a few that we can actually use. Fiber optics, again, transmits the speeds of light, significant in the last 5 to 10 years. Fiber optic holds several significant advantages. Very long transmission paths, up to miles, without any significant degradation immunity to external electronic forces, very wide bandwidth. The video switcher accepts video signals from many different videos, cameras, and connects them to one or more monitor or recorders using manual and automatic alarm systems. The standards, there's 4 basic standards: manual, sequential, homing, and alarming. Shows how these are connected to the video. The manual switcher microprocessor controlled. When the security system requires many cameras, the various locations with multi-monitors and other alarms, input functions, a microprocessor controlled switcher and keyboard is used to manage it. Large security systems, the switcher microprocessor. Numerous comprehensive manufacturers make comprehensive keyboards, operator, computer control consoles that integrate the function of the switcher, pan, tilt, pointing, to make sure it's easier to use. Quad multi-mixers, multiplexers are used when multiple camera scenes need to be displayed on one video monitor. It interposes between the cameras and the monitors and allows it to have multiple screens being seen, displaying up to 2, 4, 9, and 32 separate scenes. Most popular present is 4 scenes to allow viewing, because otherwise it'd be too small. Loss of resolution that we'd have to look at, so we have to make sure that has that also. Monitors can be divided into several: monochrome, color, CRTs, LCD, plasma, computer displays, high definition. Each one, as we get newer computer, CRTs, color, monochromes don't really exist anymore. Computer displays are now much more of the matrix of what's used. Monitor size does not necessarily have any effect. It's about the resolution that we have. You can have them up there. Even basic computer screen can be used. Before the 1990s, it was a CCRT, a monochrome CCTV that would have it on it, usually small. Most popular, they were mounted, triple mounted on there with the 5-inch monitors, and they'd be able to see what was happening. Widespread use, size 3 inches to 27 inches, and you were able to have these up on the screens. Monitors today that sell LCD and plasma are more common. They are the most expensive. Screen size from 20 to 42 inches, but you can fit a lot of different little screens on it, so you can have what's going on. It's great we have all this wonderful monitoring, but we need to record it. Back in the day, VCRs were the most common way, changing out the tapes every couple of days. They would be rewritten, the degradation, so we'd have to make sure. Nowadays, it's DVR, network recording, optical discs, so now the space doesn't degrade, and we can reuse it over some amount of time. Can be recorded in real time to make sure that we have the latest technology. VCRs is a magnetic tape. As I said, DVRs are the most common right now. Optical disc storage, both have advantage, retrieval time, and now it could also be sent right over the internet. So again, DVRs are the most common. VCRs, really old school, aren't really used. DVRs is a recorder of choice, magnetic stores, available, multiple channels, allows everything on it. Hard copy video printers, if you need to make a printer or duplicate, you can print it out on the thermal paper, so we can have that. Auxiliary equipment, camera housing, camera pan, tilt mechanisms, camera identifiers, VMDs, image splitters, 2 accessories most often used in camera, monitor and transmission links that we have to have. Camera housing, indoor and outdoor camera housings and lenses from dirt, harmful chemicals, environment, vandalism. The most common house is a rectangular metal box with a plastic painted steel. So we have that. Some can be cylindrical, some can be dome. Standard rectangle protects from the environment. The dome, simple monocolor, mounts on anywhere. Specialty, there are many specialty housings for formatting in elevators, ceilings, walls, tunnels, combining the plug and play. Today, everything is much more accessible. Pan and tint, we could top mount, side mount, dome mount, motorized mechanisms. Again, if we want to be able to zoom in on a specific area, we're able to. The video motion detector, again, this is where cameras are today, another important component. The video motion detector signal can be built into the cameras in separate components. This is becoming more and more common, even on low-end cameras such as a Google camera. Screen splitters split the screen as many times as you want. 2 or 3 combines the scenes, displays them onto one monitor, making it easy to find. Camera video annotation. You can have the cameras identified on where they're located, so whoever's looking at it can look right away to see where everything is. All right. We'll take your quiz. We'll look at the next chapters 21 and 23.